We said that the opcode in all instructions in 8085 microprocessor is 1 byte or 8 bits long. Since 2 to the power of 8 is equal to 256, it means that we could have this number of different instructions in 8085, but this CPU uses only 246 bit patterns of the opcode. Therefore, we have these many instructions. Out of these instructions, we have 85 of our instructions assigned for transferring data inside the CPU between registers and also between the CPU and memory. So all the different scenarios for transferring bits and data is like this. Is that the programmer might want to transfer a byte or 2 bytes to registers, which we call immediately, like immediate addressing mode it uses, or we might want to transfer data between register and register, between the register and memory, or memory and register. We don't have any instruction to transfer data between memory and memory. Like if you want to transfer data from the address 1000 to the address of 100, first we need to bring the data from that address in the memory to one register and then send it to the other address from register to the memory. So we have 85 instructions for all of these things. Out of these 85 instructions, 64 of them are in this format. Even though they are not only for register to register, they are also for memory to register and register to memory, but they are in this format. Now you might guess that when we mean that, we have something called M, which is from a memory cell which the HL register pair is pointing to one of the registers. So let me show you all the different 85 instructions. As we promised, we want to go over all the instructions one by one. That is the only way that you could completely completely understand all the instructions and everything about the 8085 microprocessor. So the first group are these, the first eight instructions that I wanted to talk about. The opcode, all of them, even though you don't need to memorize the opcodes, but we give you a good method of how you could somehow guess the opcode of different instructions. So these 8 instructions, the destination is the A register. We have 7 general purpose registers, which would be the source, which its contents would go to the A register. So the first instruction, move A to A, obviously the content of A wouldn't change. The next one, the contents of the B would go to A, then C to A, D to A, E to A, and so on. The last one, the contents of a memory cell who's been selected by the contents in the HL register pair would be moved to the A register. The length of all of these is only 1 byte. And if we want to talk about the steps taken, it would be like this. These 7 instructions, the step taken first is fetch, which the opcode should be fetched in the IR register. Then the transfer would happen. We don't need any read or write to or from the memory. But the last instruction, we need 2 steps. The first one would be fetch, and then we need to, the CPU would need to read the data from the memory by putting the contents in the HL register pair on the address bus, and one memory cell would be selected. The data on that memory cell would be read inside the A register. So these 2 steps would be F and R. And right now I want to give these steps a name. The name that we want to give to it is just machine cycle. We haven't talked about what machine cycle is that from now on, instead of a step, I just call it machine cycle. So the execution of every instruction would take several steps or several machine cycles, even though you don't know what that means, but it would be like this. So these 7, the first 7 instructions, it would take 1 step or 1 machine cycle. The last one would take 2 steps or 2 machine cycle. Obviously, it means that it would take longer to get executed. These were the first 8 instructions in the 8085. The next 8 would be, well, you could guess that the destination now would be B. All the other things would be the same. A to B, B to B, the contents wouldn't change. C to B up to M to B, which again a memory cell has been selected by the contents of the HL register pair. The contents would go from memory to the register, and like before, the steps would be absolutely the same. Then the C would be the destination, then D would be destination. After that, the E, this would be the E would be the destination, and H and L would also be the destination. So the last one, the last 8 instructions in this group would be M would be the destination. So here again, the contents of one of the registers would go to a memory cell that has been selected by the contents in the HL register pair. Here would be B and so on. So these were the first 64 instructions out of the 85 that we are talking about in the transfer. Now I want to tell you how you could guess the opcode of all of them. In 8085 microprocessor, 3 bits has been assigned for selecting the registers. We say B, C, D, E, H, and L alongside M and A. The 8085 assigns this number to the registers 000 for the B, 001, 010, 011, 100. Why 3 bits? Because 2 to the power of 3 is equal 8. We have addressed 8 different things using 3 bits. So we are using the 3 bits for addressing all of these registers. Now, how does the assigning opcode works? It's in this format. We know that the transferring data instructions is the first group of instructions in 8085. So we say 0 and 1 would be the opcode, the first 2 bits of the opcode of all of these 64 instructions that we said the opcode is only, the instruction is only 1 byte long. So 0, 1, and then the next 3 bits would be the destination, and the next 3 bits would be the source. So if we want to understand the opcode or the instruction for move A and C, we say this 0, 1 is common in all these 64 instructions. Then these 3 bits is assigned by looking up this table. The destination is A, right? So we look here, we say A, the 3 bits assigned for it is 1, 1, 1. So I just write 1, 1, 1. Then we get to the next 3 bits, which would be the source. Right now, source is C. Again, by looking at the C, C is 0, 0, 1. So this would be 0, 0, 1. If I separate them by 4 to understand the equivalent hexadecimal, this would be 7, and this would be 8 plus 1 would be 9. So 79 in hex, or this value in binary, would be the opcode for the instruction move A and C. Meaning, if we have 79 in hex in the IR register, or this value, the CPU understands that it should move the value of the C register inside the A register. Let's just make another example. Let's say we want to move the values inside the D register to the H register. So again, we just look up the table. We say 0, 1 would be the first 2 bits. Then we look at the table. H is the destination, which is 100, and D was the source, which is 010. So 100 and 010 would be the next 3 bits. This is for the H, this is for the D. And if we separate them in the 4, this would be 6, and this would be 2. 62 in hex is the opcode for the moving the contents of the D to H register. So these were the first 64 instructions. We are left with 21 more instructions until we complete the transfer group instructions, and then we move how these instructions are actually executed inside the CPU.